Module number 6. In 2 weeks, we'll hit the halfway point. Here is your picture of the week. It looks legitimate, almost legitimate. The message itself looks pretty much right on par. The thing that sticks out, if you're not paying attention, is the email. That's not how you spell notifications, and that's not Microsoft. And I thought this was going to do, that's weird. Not exactly the pictures I wanted it to show. Anywho, I'll just share this instead because it looks like the slideshow isn't working as expected. And if you haven't noticed yet, my lecture notes are all in Canvas. That's what I use. So if you're thinking, where am I reading stuff from if I get stuck or something, it's all here. Anywho, security through network devices. First and foremost, our devices build out the infrastructure that we use. That is kind of a duh. But we often forget to protect those devices, to set security measures on them, because they're just part of the infrastructure. Yet they need to have protection just like everything else. The first item on our list is bridges. Bridges are awesome to join two separate networks together without the need of a router, especially if these two networks are layer 2. The problem with that is exactly that. Because it is a bridge between these two networks, this needs to be protected. We should not just build a bridge between two networks and not have something in the way to ensure that communication is secure. If we're talking about two buildings, let's say this is building A and this is building B, and we have a wireless, like a microwave between one and the other, we need to ensure that that communication is encrypted. Because if we're using the air, then that means anybody can sniff those packets. Anybody can see what's happening. If it's a wired, not so much. But nonetheless, if you have any form of bridge connecting two networks, that needs to be secure. Because if that is compromised, now any and all traffic flowing in either direction can be read and can be used. Our next item is switches. Specifically smart switches who have 802.1d on. 802.1 should be on in order to mitigate broadcast storms. That's when we have packets flying all over, slowing down traffic throughout the network. You don't want that to happen. You also don't really want switches to turn into hubs, entering that fail open state. Because during the fail open state, any and all traffic is routed through all ports. While it sounds like a great backup, it also means if the attacker is sitting on that switch, let's say PC2 is our malicious attacker who successfully got switched to enter the fail open state and turning into a hub. Now it can see all the traffic going in and out for PC 1 and 3. That includes any and all traffic because that's exactly what a hub does. So you want to prevent things like broadcast storms of affecting switches, and if possible, preventing those switches from becoming hubs. When's the last time you checked your home router settings? If the answer is never, if you're scratching your head thinking, when did I check my router? That's not a good thing either. Your router is the gateway out to the world. If that is not checked, if you are not looking at the settings and implementing security measures on it, well, it's basically the same as having a door but not locking it. Now, routers are the first device that packets reach when they're entering your network outside of a modem. So your router should have some form of access control list to prevent any unwanted traffic making it into your network. This is especially true if you have routers that are no longer supported by vendors, which is true of a lot of home devices. The next device is a load balancer. Not necessarily used at homes, but used in businesses to handle large amounts of traffic in and out to their application, whether it's web, whether it's database, whatever the case may be, email. These, again, need to be protected. They need to prevent certain errors from making it out, because that is what attackers will use to formulate their attack. If it just so happens that it is possible to use the load balancer to get information like what application is hosting a website, whether it's Apache, Nginx, Tomcat, well, then that narrows down what we search for when it comes to an attack. If I find out that, oh, this company is using Apache, then I don't need to go and find any vulnerabilities for Nginx. They're irrelevant. You want to ensure that load balancers do not let errors out to the wild. We also have proxies, which if you have attended a school, a US school in the last, I don't know, let's say 20 years or so, you probably used to try to circumvent the content filtering in your school. There are four main types: the forward, the application or multipurpose, the reverse, and the transparent proxies. They all do the basic function of a computer, a user makes a request to go to a certain website. That request reaches the proxy server. The proxy server then makes that a new request on their behalf out to the internet. It looks like it is this proxy who made the original request, but it knows who made the original request. So when that response comes back, it'll hit the proxy server, and then the proxy server forwards that back to the originating host. It is slow, but that is how proxies work. Proxies are great in the sense of security because from the outside world, it looks like everything is coming from this one source. You don't know who is on the other end. This also means we have to protect our proxy servers if your network implements them, because should a proxy server get compromised, now you see who's on the other side. The same thing if we're talking the other way. If we are running web servers and we have a reverse proxy in place, if this gets compromised, now an attacker can find out how many servers are in the back end if they want to craft a DDoS attack, for example. Your network security hardware. First and foremost, which you should have, is a firewall. You have them existing in hardware form, and you have them existing in software. These should be set, especially host-based, should be set to implicit deny. So that way, only network internal network resources use what's within, not just out to the world. Network-based firewalls can be stateless or stateful. Stateful is the one that is a little more smarter because it looks further into the packet than stateless. All of them have access control lists that should be implemented. There are also application-based firewalls that focus solely on the application layer, like the layer 7 of the OSI model. The most infamous of these is the web application firewall. Obviously, by the name, it only focuses on the web application. So if you have a server who is a website and you only have the web application firewall on, you may be exposing the rest of the system to a vulnerability. And then it doesn't necessarily matter that you have this web application firewall if the host system is open and vulnerable. These are all the layers that you need to keep in mind as you secure your infrastructure. You could also use VPNs, especially in this age when all of our workers are at home and are not going to come into the office, but they need to access documentation, they need to access network resources to do their job or network applications. How do you do that without opening holes yourself? Well, one way could be a VPN. That also means your VPN, whatever device you're using, needs to be protected. Because if that gets breached, it doesn't matter that everybody else is secure. Malicious actor made their way in. If you are hosting your own mail server, that too can be a way in. Because email has a lot of sensitive data. So if you are running your own in-house email server, that needs to be protected. Here I have a picture of an intrusion detection and intrusion prevention system. The main difference between the two is prevention will stop anything that looks malicious, it will stop. Intrusion detection will let you know that malicious activity may still happen, but it will send you an alarm. Prevention will cause an alarm and block at the same time. Now, at first glance hearing this, you think, oh, it's easy. Let's just do intrusion preventions because it stops the attack. That logic doesn't always work in every case. If we're talking, let's say this is a web server, but we don't really want all our web connections to be blocked, especially if they're legitimate users who just so happen to do the wrong thing. Or what if they have an extension that is causing them to do something funny? It's better to see what's happening and make that choice rather than have it automatically block. There are a number of products that you can use, both freely available and commercial, along with host-based intrusion detection and prevention systems that you can actually configure together into one big monster that watches not only what's happening on the network, but on the individual hosts. That is the kind of system you want to implement. You want to know what's happening network wide so that you can make fully educated decisions. We also have SIEMs, the Security and Information Event Management. These are awesome. They aggregate all the logs from all systems together into one place. So rather than looking at events in one system and then jumping to another, you can breathe and execute from one location. The one that we will focus on is Splunk. Graylog is another that you could use, or the Elk stack is another that you can use, but we're going to focus on Splunk because they are still the leading SIEM system out there. And if you know how to use Splunk, you can understand how to use other systems. Oh, look at that. I think my slideshow will work. I don't know what happened with that first slide. Well, let's see. If it doesn't work, I'll just go back to the content itself. Your network architecture should be built in a way to ensure security. For example, having a demilitarized zone, a DMZ. We have our router that faces to the internet. Traffic comes in. The router decides that this is a valid packet looking for our service or our services, forwards it over to the firewall. The firewall looks at that packet and decides, is this something that goes internal or something that goes to the DMZ? Things that we know that need to go out to the internet, such as a web server or an email server, those should be on a separate network. And that's what this demilitarized zone is. It's a separate network, ideally a completely separate network. As you can see here, we have two switches. So we have air gapped at this point from the firewall on. We have this whole network separate from this network. So if a breach occurs, it does not leak into our internal network. Network address translation, which only works for IPv4 networks, is another way of implementing security through our network. Similar to Proxy, where we take an IP address of an internal device and we mask it to look like another IP address of the router, for example. So when that goes out to the world doesn't necessarily know who is the actual device who is creating this communication. This is also available for ports as the port address translation. But this only works for IPv4. IPv6 has no need for it because there are way too many available addresses that we don't need to do NAT and PAT, although you could do it. You could do NAT and PAT for IPv6. It's not necessarily needed. I mentioned it earlier with the DMZ. Having network segregation, especially depending on the data, the level of sensitivity, whether it's confidential, secret, top secret, you may need to physically put devices on separate networks, and that's air gap. You could also segregate networks by virtual LANs or VLANs. A pro tip, do not use common numbers for VLANs. It is common that VLAN 1 is the management. It is also common that the multiples of 10 are used for VLANs, as in this example, 10, 20, and 30. I say that because it is possible for an attacker to create a packet that is double tagged. So let's say we have a malicious person who logged into VLAN 20, but wants to get into VLAN 30. Well, it is possible to create a packet that has VLAN 20 tag and the VLAN 30 tag. So when it hits the switch, it'll take off that tag, see that it's VLAN 30, and pass it on to VLAN 30. Just because you have VLANs does not automatically make the whole system secure. It is possible to circumvent these methods. Network access control is what's displayed here. Allows administrators to put new devices in quarantine states, while a network access control agent installs or runs in memory. This is useful, especially in the BOID, the bring your own device networks, where you don't know if that device is secure. You don't know if it has all the latest patches. You don't know if it's infected. By running a network access control agent, whether installed or running in memory, you can see into the system if it is safe enough to join your network. If it's not, you kick it out. If it's safe enough, you can let it in. There is also data loss prevention. A lot of businesses need this, and they're not implementing it. DLP is invasive because it's watching everything that's coming in and out. So this requires your organization from the top level down to be okay and understand that any and all traffic is being watched. So there is no privacy when DLP is in play in a network. Because the whole purpose of DLP is to watch what traffic is coming in and out and prevent any leak of information. So if somebody tries to, let's say, attach an email into an email, some data that is deemed sensitive, that is deemed property of the company, DLP would block it from leaving the network and notify the admins. Same if it was being copied to a USB. Again, this means that DLP is going to be invasive. It's going to watch, it's basically a piece of malware. It's acting as a keylogger, it's acting as a Trojan horse, it's exfiltrating data all the time and putting that hopefully in a secure log that a legitimate administrator has access to and reviews. But on the other hand, DLP allows you as a network administrator to see what's happening, to be able to notice any signs of a potential insider threat or a disgruntled employee who's trying to take information out before they quit or before they get fired. That's where DLP saves the day. But it comes with the cost of losing privacy. Any questions? Looking for questions in the chat, looking for questions in Discord. VPN, it depends. It depends whether VPN could circumvent DLP. If a VPN connection is established at this device, at the end device, then it's possible because anything in the network would just see encrypted traffic. And that's if the DLP is set up at the network level. If there is also an agent within the, let's say this is a work computer and there is a DLP agent installed here, then a VPN makes no difference because it's looking at the actions within that machine. It would be the equivalent of copying to a USB. It wouldn't matter. But if the organization doesn't have a agent on the end device, then it's possible to use a VPN to circumvent a DLP. Other questions? No? Okay. So let's stop this.